So what I was saying is that when we use these different um, torque transmission elements like set screws, keys, pins, they all come in standard. And for example, set screws are available in different tips, and these are the different tips of the set screws, and you would have seen them. But the standard dimensions of these set screws are given over here. ठीक है जी? Have a look at it in your book and in this presentation. If you look at this, what we have in a set screw is there is a holding power. And what is that? The resistance to axial motion of collar or hub. अभी जो मैंने कहा आपको कि hub या collar, when you have sorry, when you have a pulley, oops, there is this hub, and the shaft basically goes in here. ठीक है जी? And what you do is you put a set screw over here. ठीक है जी? So the resistance to axial motion of the collar or hub, this is the hub or collar or hub, is known as the holding power. Typical values are listed in table 7-4. So what does table 7-4, which is this table, it gives you typical holding powers or force for socket set screws. So these are the holding torques, like for seating torque or holding power. ठीक है जी? तो ये आपको दे रहा है holding power with these seating torques. The typical factor of safety that we are incorporating when we are using these set screws is about 1.5 to 2 for static and 4 to 8 for dynamic loads. Length should be about half of the shaft diameter. So length of these set screws should be about half of the shaft diameter. So while using your set screws, you should keep that in mind. Now, keys and pins. Keys and pins are used to ensure the rotating elements and to transmit torque. ठीक है जी? तो पिंस you would have seen, I'm pretty sure कि आपने pins देखे होंगे where it goes across the into the shaft in a hole. These are different pins, like pin, and these are keys. ठीक है जी? um, let me see if I can find an example, a real example of see these pictures. Do you see these pictures over here?
Yes, sir. Yes, sir.
These are keys. And if you look at, especially looking at this picture, you see that these are some sprockets. ठीक है जी? And in these sprockets, you see these keyways. ठीक है जी? Um, Actually, what we can do is we can copy this image and take it to our over here. ठीक है जी? So looking over here, देखिए, these are your keyways. Okay. Do you see the slide now?
No, sir.
अच्छा जी. Okay. Do you see the slide now?
Yes.
अच्छा जी, तो यहाँ पे अगर आप देखें, दिस इज द की वे. ठीक है जी. Over here you see that this is the keyway, and यहाँ पे the keyway, and this is keyway in the shaft. Similarly, keyway in the shaft, and there is a key in there. These are keys, and keys are of different types. Um, you can see keys of different types in shafts. Let me see if we can also look at pins. ठीक है जी. Uh, these are pins. ठीक है जी. Different pins. You see them. So these pins are also standard pins, huh? You would have seen these in your tractor uh, plows. ठीक है जी. You insert them in there. Now, so let's see. What do we have here is कि आपके जो um, looking at the pins and the keys, as I said that they have different types. Let's look at the tapered pins. You have tapered pins that are sized by diameter at large end. See, ठीक है जी. You can calculate the diameter of the small end. These are your tapered pins are made like this. They are, sorry, uh, they are tapered. If this is the small diameter and this is the big diameter, if you know the big diameter, you will subtract this much times L. Uh, this is your L, so you can calculate your D from here. And looking at the table 7-5, these are some standard sizes in inches. ठीक है जी. This is the size, maximum, minimum, and for precision maximum and minimum, these are the pins that you will get over here. Now, how do you design a pin? We have done pin design, Kana? Do you remember that we have done pin design? Can you remember that we have done pin design? किया हुआ है कि नहीं? देखिए, if these are two,
No, sir. Sir.
we did already. If you recall your threads, we did a design in which we said that if this is a threaded element, if it is a bolt or a pin or a rivet, it is the same. You just take the area of that. ठीक है जी. तो यहाँ पे आपका एरिया क्या होगा? It will be D, and the cross section area will be pi by 4D square. ठीक है जी. You will look at failure in this pin. इसमें shear हो सकता है, bending हो सकती है, and things like that. So we already have done this in our when we were discussing threaded joints. ठीक है जी. So whatever force we have, we can design a pin for that. We can suggest a pin for that. Achha, similarly, keys come in different forms, and I'm sure that you have heard the names of these keys, like for example, square keys, rectangular keys, wood rough keys, and so on. So keys come in standard square and rectangular size, and shaft diameter determines the key size. For example, यहाँ पे if you look over here, it says shaft diameter over or to include. Um, so you will have a key with um, W and H, and the keyword depth in the shaft should be this much. ठीक है जी. Basically अगर आप key को देखें तो what do we have in keys is that key is by either direct shear, key failure is by either direct shear or bearing stress. Now, how do you calculate stresses in a key? Okay, key क्या होगी? Let's just take a square key. ठीक है जी. तो you will have some length of the key. ठीक है जी. And you will have that W and H of the key. ठीक है जी. तो if it shears, what will shear? Basically, this area will shear. What is the area? क्या होगा? What will be this area?
W cross H.
Hmm? W cross H.
H, sir.
ये तो इस डायरेक्शन में है ना. This goes into the shaft with this length. ठीक है जी. तो what's going to shear? This is going to shear over here. देखें ये यहाँ पे shear होगा ऐसे और ऐसे. So it will be W times what? And this is going to split into half this way. तो shear area क्या होगा?
Half of H,
Isn't
W
it going
cross
to
half
be
of.
this? Isn't it going to be this? ठीक है जी. तो W times L होगा, right? So basically we want to keep this key the weakest because we want this to break, not the shaft or the component that we have mounted on the shaft. Gear agar hai, we don't want that to break. If it's a pulley, we don't want that to break. We want the key to break. So key length is designed to provide desired factor of safety. Factor of safety should not be excessive so that inexpensive keys is the weakest link. We want this to break. Keys length is limited to the hub length. ठीक है जी. And key length should not exceed 1.5 times of the shaft diameter to avoid problems from twisting. You can use multiple keys, you can use them, you can use one key, or you can use many keys typically oriented at 90 degrees from each other. um, a stock key material is typically low carbon cold rolled steel hota hai. um, and with dimensions slightly under nominal dimensions to easily fit into an end milled keyway. ठीक है जी. A set screw is sometimes used with a key for axial positioning. So because set screws are used for axial positioning and these ones are used for torque transfer, so this holds the set screw holds the component in axial direction while the torque is transmitted through the key. There are other keys, jib head key. This is a jib head key, and I would, ask you to have a look at the jib head key. Basically, the head is has a projection over here, and so that it makes it easy to fit in, assemble and disassemble this key. ठीक है जी. Then we have woodruff key. You can also look at the geometry of a woodruff key. ठीक है जी. These are the height, offset, and key seat depth for the woodruff keys. If you look at this table 7-7 and 7-8, uh, the stress concentration for keys, as we already discussed before, okay, for keys cut by standard end milled cutter with the ratio of R over D equal to 0.02. Peterson's charts give आपका जो KT है for bending, torsion and for torsion with the key in place. These are the values that you are going to use for the stress concentration. Keep the end of the key seat at least a distance of D by 10 from the shoulder fillet with that will prevent the two stress concentrations from combining. ठीक है जी, तो these are the layouts that you would keep in mind. This is a problem that says that a UNS G10 350 steel shaft heat treated with a minimum yield strength of 75 kpsi has a diameter 1117 by 16 inches and the shaft rotates at 600 revolutions per minute, transmits 40 horsepower through a gear set at an appropriate key for the gear. ठीक है जी, so you will have, let's say this is the thickness of the key, ठीक है जी, and we have this figure shown over here. So the torque transmitted, we already know that it is 63.025 H over N. We know the values of H and the revolutions, so you will find your torque. This is the torque that needs to be transmitted. So from figure 7-19, the force at the surface of the shaft basically आपका T किस चीज के बराबर होगा? T is equal to F times R. So we'll have F is equal to T by R. Now go ahead and your diameter जो है that is 1.4375 divided by 2 will be your R. So this is your force now. We already know कि आपका जो shear yield होता है that is equal to 0.577 times of the yield strength. So go ahead and calculate your shear yield. ठीक है जी. And for failure, as we already know कि आपका जो what will be your N? Failure by shear across the area, वही चीज है कि you will take the area. AB will create a stress of tau equal to F over TL. ठीक है जी. Substituting the strength divided by the factor of safety. ठीक है जी. This is your factor of safety. So you can go ahead and and put the values in there. तो आपके पास जो है you will find your L. ठीक है जी. So the L is in shear yield, and in yield your length is either this or this. ठीक है जी. So if the key in this example is made equal to the length of the hub, it would have a force that has ample strength. So therefore 17 by 16 inches or longer. ये आप इस्तेमाल करेंगे. ठीक है जी. Look at these retaining rings. You would have seen these. These are just retaining rings, and we put them for positioning. You would have seen these in your toys, in equipments that we remove this. ठीक है जी. It's over here. You remove this, and then this thing can come up. So it just holds that in position. Again, these are standard retaining rings. ठीक है जी. Stress concentration factors for the grooves to put in these retaining rings are available in table A15-16 and A15-17. When you use these typical stress concentrations around 5 for bending and 3 for tension up इस्तेमाल करेंगे. We already did these limits and fits in the previous semester, machine design 1. ठीक है. So this is the end of